So, good morning, everyone, and welcome to the third day of this faculty development program on recent development in mathematical sciences and engineering, sponsored by AICTE Training and Learning Academy, ATAL Academy. So, in this third day, we have with us Professor S.C. Arora, and he is going to share his views on from logic to fuzzy logic. And for his formal introduction, I would like to invite coordinator of this FDP program, Professor Renu Chuk ma'am. So over to you, ma'am.
Thank you, dear Dr. Ekta. Thank you so much. I think Professor Arora needs no introduction because he's a renowned mathematician from Delhi, retired from Delhi University. And he's a mentor to us and you can say family member to us also, this from our mathematics family, Department of Mathematics. So first of all, sir, welcome, sir, in the session and sparing your valuable time. We are really grateful to you, sir. So for Professor S.C. Arora, he passed his MSc from Hansraj College, University of Delhi in 1967. And he stood first in the university. After passing MSc, he was immediately appointed lecturer in Hansraj College in July 67 itself. And he taught there for 20 years. And then he moved to Department of Mathematics, Delhi University in 1987 as reader, Department of Mathematics, and then subsequently professor, and later on also he served as head of the Department of Mathematics in Delhi University, and he superannuated on 31st May 2010, and then after that he was associated to PDM College University and then SGTB Institute of Management and Information Technology Delhi for next 6 years. He's still working very efficiently. He's busy and always in academic activities. At present, he is a member of advisory committee of various academic institutions associated to different Indian university and contributing his expertise as a subject expert to other universities, colleges also. Professor Arora has written more than 100 research papers published in very reputed journals all over the world. His research is being referred and work is being done over his research throughout the globe. He is a renowned figure. Many operators on which he has worked basically on operator theory, and many operators on which work is done have been introduced by him, rather. And we are fortunate to have him here. And some of these are generalized stand topless operators, Henkel operators, star paranormal operators, M star paranormal operators, and many more. He has visited many countries and delivered many lectures at national and international conferences, along with popular invited talks in almost all the colleges of Delhi University. He has been associated to UGC, AICT, DRDO, ARI, NCERT, CBSE, DST, SCERT, etc., all the prestigious institutions of India. He had also been associated to many universities and public service commissions, very prestigious institutions. He is still associated with, and he has contributed a lot to mathematics education, even at school level, and has been associated to many schools of Delhi in some capacity or others. He has delivered lectures at various universities of India and abroad in some capacity or the other, and known to be a very popular teacher. Sir, we are very fortunate to have you with us for this and delivering this lecture on the very emerging topic that from logic to fuzzy logic. Thank you so much, sir. Please, over to you, sir.
Thank you. Thank you, Professor Renuto. Thanks to Professor Rajiv Kumar for making me a part of this FDP program. I feel very excited to talk about these popular things. So, in any case, therefore, I pay thanks to you for giving me an opportunity to talk about these general things. Well, so much has been said about me. I do not know whether I deserve that much praise or not. I don't consider myself to be singled out, for all these things. for all the achievement which you were talking about. My only qualification you can say is one, just one. That is, I had been going to my class very regularly. Never tried to miss any class. Never missed also. There were no opportunity. There is no occasion to when I missed the class. But that's the only qualification. Everything else is a corollary to see that qualification. So, but in any case, see, I pay thanks to all of you, particularly about Miss Renuchuk, Professor Renuchuk, who had been very cordial towards me every time, every day, whenever there is any occasion, she doesn't miss that chance to invite me to talk to you people. In any case, coming to the topic is from logic to fuzzy logic. Well, my first part would be devoted to logic. Second part, of course, would be talking about fuzzy logic. Well, I take all of you to a session court. There is a murder case in the court of a session judge. There is no eyewitness in the case. Public prosecutor says that the accused was seen with the victim half an hour before the incident occurred and nobody else met him thereafter. Therefore, logic says the accused is the real culprit. The defense lawyer says that the arguments given by PP are far away from logic. At the time of the incident, the presence of the accused has already been established at some other place. Businessman, while trying to influence his customer, says logically, our product is the best one because we are in the greatest demand. The leader of a political party says that logically this time also, we are going to unfurl the flag at Red Fort on the Independence Day because no leader of our party is involved in any case of corruption. People from all corners of life make use of this word logic in some form or the other. Be it a policeman, a gunman, a watchman, a hitman, or a postman, a mathematician, a statistician, a magician, a musician, or a beautician, a chemist, a druggist, a florist, a dentist, or a typist, all use the word logic in some context or the other. Let us see that it is only an English word or it has some mathematical background. It is to be seen because why a person belonging to mathematics, see who had been head of comes talks about a word used by everybody or it has some mathematical input. See, what is logic, what is mathematical logic or symbolic logic? Let us try to see. I'll firstly go to the precise definition of logic given by various people at different times in different ways. In mathematics, we are constantly engaged in giving proofs of many statements that we make. Procedures that we employ in mathematical proofs must be based on some sound reasoning. The study of these procedures is called logic. Logic is sometimes defined as science of proof. Logic is a weapon. We need to convince others that granting our postulates are valid, certain conclusions must be valid. Logic is an extensive field of study with many special areas of inquiry. In general, logic is concerned with the study and analysis of methods of reasoning or argumentation. Logic is a systematic study of the structure of proposition and of the general conditions of valid inferences. Logic is a theoretical study of the structure of reasoning. These were the various definitions given by various thinkers, various philosophers, various mathematicians regarding logic. Let's see how see which way logic came. Let's try to trace the history of logic. Logic into an independent science long ago, earlier than arithmetic and geometry. And yet it has only been recently, after a long period of almost complete stagnation, that this discipline has begun and it has undergone a complete transformation with the new status similar to that of their mathematical discipline. In this new form, it is known as mathematical or deductive or symbolic logic. Logic was created by Aristotle, the great thinker of the 4th century BC, from 384 to 322 BC. His logical writings are collected in his work Organon. As the creator of mathematical logic, we have to look upon the German philosopher and mathematician of the 17th century, G.W. Leibniz, same Leibniz which you study, Leibniz theorem for the nth derivative of the product of two functions, the Leibniz test for convergence, same Leibniz. Okay. However, the logical works of Leibniz failed to have a great influence upon the further development of the logical investigation. There was even a period in which they sank into complete oblivion. The continuous development of mathematical logic began only towards the middle of the 19th century, namely at the time with the logical system of English mathematician George Boole. George Boole, he was a mathematics teacher in 1854. George Boole, professor of mathematics at Queen's College, Cork, London, published a book called An Investigation of the Laws of Thought on and probability. So far, the new logic had found its fullest expression in the epochal work of the great and Whitehead, 1861 to 1947, and Bertrand Russell, 1840 to 1913. In his book, Principia Mathematica. Logic is then transformed into propositional calculus. What is propositional calculus? I'll let you know. Historically, propositional calculus began with the work of German logician G. Frege, 1848 to 1925, who without doubt was the greatest logician of the 19th century. The eminent contemporary Polish logician and historian of logic, Lukasiewicz, succeeded in giving propositional calculus a particularly simple and precise form, extensive investigation concerning the propositional calculus. In the discussion of logic, what logic comes to? In the discussion of logic, whenever we discuss it, the treatment centers around the concept of a proposition or a statement. What is that? Precisely speaking, proposition is any meaningful, unambiguous, declarative sentence which is either true or false, but not both at the same time. Okay? And to tell you, study of proposition, study of Boolean algebra, study of step theory, and logic. This totally logic is called as all these are if one knows one concept, one comes to know the other concept also. There are various ways in which the proposition can be combined to form the other statement. Next is, logical arithmetic. See, P is the statement, true, false, Q, false, true, false. Then P plus Q comes to that. PQ comes to the intersection. This is same thing as union of two sets and intersection of two sets. And P dash, the complement of a set or the negation of the statement. Negation of the statement or complement of a set, they mean the same thing. And P implies Q is the same as P dash plus Q. P dash being the negation of P. Q, F, Q, and T. The first thing that I'll do is I'll talk about an application of this logical arithmetic. An application of logical arithmetic. There are two restaurants next to each other. One has a sign that says good food is not cheap, and the other has a sign that says cheap food is not good. Are both the signs saying the same thing? This is the question. Okay? One says that good food is not cheap, and the other says cheap food is not good. Are both the signs saying the same thing? Okay? Let's say they are saying the same thing. How? That G denote, I justify this by statements, by propositional calculus. That G denote the statement that the food is good, and C the statement that the food is cheap. And the first sign says G implies C dash, and the second sign says C implies G dash. It will now be clear from the following truth table that one is the contrapositive of the other, and hence they mean the same thing. This is the truth table. G, C, G dash is this, and C dash is this one. G implies C dash becomes T, 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 F, and C implies G dash also becomes T, 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 T. So truth table justifies that they are saying the same. Next, I'll justify the use of logic. Logic, that is analysis of reasoning. Logic is nothing but analysis of reasoning. And look at what the surprising thing it comes to. In any gathering of 6 people, there are either 3 people who all know each other, or 3 people, none of whom knows either of the other two. Proof of this assertion. We draw a graph in which we represent each person by a vertex and join 2 vertices by a solid edge if the corresponding people know each other, and by a dotted line if they do not. Therefore, the problem in the language of mathematics becomes the following. In joining 6 points in a plane, there is always a solid triangle or a dotted triangle. Now, kindly excuse me, I am coming within 2 minutes. Video.
So, dear participant, you can write down your queries in the chat box only, so that we can ask that query in the last of the in the end of the session. Somebody want to know that how they can unmute. We are not allow you to unmute in middle of the session because that creates noises sometimes. So that's why we lock that muting or unmuting yourself option from your side. So you can just write down your query in the chat box. We will
Take care of that.
yes, we will take care of that to ask that query in the last. Okay. Your query. Yes, for those you can write down your query here in the chat box.
तो फजी लॉजिक में नहीं
डाल देना जरा आज पकड़ ले पहले मनी So I was talking about everything clear. I was talking about. I'm sorry for the interruption. You see, I had to because I had taken medicine. Actually, in any gathering of 6 people, there are either 3 people who all know each other, or 3 people none of whom knows either of the other 2. We draw a graph in which we represent each person by a vertex and join 2 vertices by a solid edge if the corresponding people know each other, and by a dotted line if they do not. Therefore, the problem in the language of mathematics becomes the following. In joining 6 points in a plane, there is always a solid triangle or a dotted triangle. Now let A be any vertex. Then there would be exactly 5 lines joining A, either solid or dotted. Whatever we may argue, whichever way we may argue, and whatever we arguments we put in, we find that there must be at least 3 edges which are of the same type, either solid or dotted. So, and case 1, assume that there are 3 solid edges. Look at this: A, B, C, AB solid, AC solid, AD solid. E and F are left out. Now, if B and C know each other, then join BC by a solid line. And if not, then they would be joined by a dotted line. See? And we are done in that case. Supposing it is a solid one, then ABC is the required triangle. If not, then B and C would be joined by a dotted line. If C and D know each other, then join CD by a solid, and then ACD is the required triangle, and we are done once again. If B and D know each other, join them by solid, then ABD is the required triangle, and we are done once again. And if not in every case, then BCD would be the triangle where each side is dotted. If not, then they are joined by dotted lines, and then BCD is the required triangle, and we are done again. Same thing happens in the second case when there are 3 dotted lines. Then we argue in the same way. Assume that there are 3 dotted lines. Again, as before, arguing in the same way, we get the result in either case. So this shows that in any group of 6 people, throughout the world, if you take, there would be at least 3 persons. Either each of them would know each other, or none of them knows the other 2. That would be the. This is what logic. Logic justifies that this is possible. Then again, what is logic 1? That is path of valid inferences. That imagine that there is a village, in a certain mythical community, of course, in a village. Politicians, there are persons who are politicians, and there are persons, one who is not a politician. If a person is a politician, he would always tell lie. And if there is a person who is not a politician, will always speak the truth. And a person has to be either a politician or not a politician. So either he would speak the truth always, or he would tell lie always. Politician always tell the politician always tell lie, and non-politicians always tell the truth. A stranger, they are to select sarpanch of the village, and they devise this new method. That person, you know, uh, gets up in the morning and goes to the riverside and meets three persons in a row. A stranger meets three natives and asks the first of them, "Is he a politician?" The first native answers the question. The second native then reports that the first native has denied to be a politician. The third native asserts that the first native is really a politician. So, who amongst A, B, and C is a politician without any doubt, so that that person should be elected as sarpanch? This is the problem. Logically, I justify that who amongst them is not a politician. Let us see. Let P stand for the person is a politician. E is the statement. Logically, we will talk about that the person is a politician. Let P stand for the two cases are right. Case one. Suppose A is a politician. When the question is posed to A, then he would either say, yes, I am, or he would say, I am not. But let us see what our logic says. Case one, suppose A is a politician. Then what he would say? Because he is a politician and the question is posed to A, are you a politician? So certainly, since he is to tell lie, he would say, no, I have no concern with politics. I am not a politician. And B says that the first native has denied to be a politician, which he is denying. And therefore, B is not a politician because he is corroborating what A has said. Then C says that the first native is really a politician. That means he once again is not a politician. Right or not? Then, in the second case, suppose A is not a politician, what he would say? The answer that he would give, no, I am not a politician. Because he is not a politician, so he would say that I am not a politician. He says that A has denied to be a politician, which is denying, of course, in any case. So B is not a politician. C says that A is truly a politician, but A is not a politician, and therefore C is a politician because he is telling a lie. So therefore, under the circumstances, in case one and in case two, in both the cases, who is not a politician? Of course, this says that B is not a politician in any case. So therefore, and B is not a politician in any case, and therefore he should be made as sarpanch. Then, next is that, as I told you, the study of Boolean algebra is also equivalent to the study of proposition, or I would say equivalent to talking about that study of logic. Study of logic, study of proposition, study of set theory, study of Boolean algebra, they are all same study. Boolean logic, Aristotelian logic, Boolean algebra, set theory, study of proposition, they are all same study. You see, the one thing that it refers to, you see, that we are talking about, we are studying, we are talking about logic as the study of Boolean algebra. In the study of Boolean algebra, what is the Boolean algebra? A complementary distributive lattice is the Boolean algebra. That is the Boolean algebra. Or say taking union, intersection, etc. The power set of any set, you can say. The power set of any set, that is the Boolean algebra, because it has got the complement of every element, a zero, identity, and union intersection, union distributive. it's a complemented distributive lattice. That is nothing but Boolean algebra, and that is nothing but the study of proposition. That is nothing but study of logic. All these are parallel study. I am justifying now how the study of Boolean algebra helps. Study of Boolean algebra helps in solving problems of in the practical sense. Look, after marriage, a husband says to wife, at any meal, if you do not serve bread, then ice cream must be served. Secondly, if you serve both bread and ice cream, then pickles must not be served. Third one, if either pickles are served or bread is not served, then ice cream must not be served. So the question is what that poor wife should do, firstly, let her understand what her husband is saying, and then how to implement. Sometimes, you see, wife brings pickle, ice cream, etc., and husband says, no, nothing of that sort. I did not say this thing. I did not say this thing. Let us try to help the poor wife. If we look at these, at any meal, if you do not serve bread, then ice cream must be served. And if you serve both bread and ice cream, then pickles must not be served. If either pickles are served or bread is not served, then ice cream must not be served. See, in all, these three contain only three statements. Or I would say three elements of the Boolean algebra. Or I would say three propositions, three statements, or three sets. Whatever you want to say, you can take it like that. First one is B, bread is served. I, ice cream is served. P, pickles. These three. And let's see what first statement means. If you do not serve bread, then ice cream must be served. This means complement of B. B dash implies I. Secondly, if you serve both bread and ice cream, in B, that means intersection. That intersection is nothing but the product, BI. BI implies P dash, pickles must not be served. Then, if either pickles are served or bread is not served, this amounts to union of two sets, or A union B. Pickles are served means P, or bread is not served means, B dash, and union means P plus B dash. This implies I dash, ice cream must not be served. Meaning thereby, condition 1 is B dash implies I, condition 2 is BI implies P dash, and condition 3 is P plus B dash implies I dash. See? And this B dash implies I means condition 1 is equivalent to B dash dash plus I. Condition 2 is equivalent to BI dash plus P dash. And BI dash is, De Morgan laws. A intersection B dash, complement of this is A dash plus union B dash. This means B dash plus I dash plus P dash. And condition 3 is equivalent to P plus B dash dash plus, and that is P plus B dash dash is nothing but P dash P. De Morgan laws. P dash B plus I dash. So all the three should be served. That means the intersection. This means B plus I into B dash plus I dash plus P dash into P dash B plus I dash. See, using commutativity, distributivity, and also using dash dash is nothing but that one. And I into I dash is nothing but empty set. That means zero element in the Boolean algebra. This means using firstly distributivity and then applying all these laws. Finally, it comes to what? it comes to B of I dash plus P dash, and that is equal to B into IP dash. Let us try to interpret what this means intersection. This means intersection of B and IP dash. That means complement of IP dash, meaning thereby that bread is to be served always, and ice cream and pickles should not be served together. This is the answer to this problem. The problem solved with the help of Boolean algebra. It comes to that thing. Then, next, the study of switching circuit is also the same as study of logic, study of two-elemental logic. You see, when you see the switch is either on or off. And on, off, 0, 1, 2, false, yes, no, you can see they are all equivalent statements. If switch is either on or off, an element belongs to the set and or belongs to its complement, not to both. It can either belong to A or can belong to B, or can belong to its A dash. Then A union B, X belongs to A union B means X either belongs to A or B. And A intersection B means X belongs to A and B both. Switches also, they behave exactly in the same way. The first one, this is a series connection. Switches can either be connected in series or can be connected in parallel, or if switch is on or switch is off. This is series connection. The current can pass only when both the switches are on. X can belong to A intersection B only when X belongs to A and X belongs to both. A statement P and Q can be jointly P intersection Q, and then P plus Q and P dash. Next is, it is parallel connection. It is equivalent to A union B. The current can pass when any one of the switch is on, and that serves the same purpose. And the third one is that complement of a statement. The complement of statement, or a switch is on, or either on or off. They behave exactly in the statement, the propositions, they behave exactly as the switches are behaving. You can see parallel, P dash, and P plus Q, or A union B, or the statements are, both the statements are true. Either one is true, either one is true or false, and etc. They can behave as the elements of the Boolean algebra. And therefore, if that is so, if they are elements of the Boolean algebra, then can we apply Boolean algebra to switching circuits? Yes, we can, because they are behaving in the same way. And let's see, therefore, the switching circuits, the study of switching circuits can also be studied with the help of Boolean algebra or lattice theory, or you can say the study of proposition, or with the logic X belongs to A intersection B means X belongs to A and B both. X belongs to A union B, that X will at least belong to one of them. And X can either belong to A or can belong to A. The study of switching circuits can be made useful in two ways. One is the simplification of the circuit using Boolean law. We take a complicated circuit, it make them with the help of Boolean algebra as Boolean expression. Apply the laws of Boolean algebra to simplify that complicated circuit. That means a complicated circuit with the help of Boolean algebra can give you the same result as a very simple circuit. And that actually tells you how to save wire, the cost of wire, etc., with the help of Boolean algebra. Or second is to design. That you can design also using Boolean algebra. See, for an application, I have chosen as designing a circuit as an example, as designing a circuit, and see what it is. The problem is design a circuit involving a landlord L and two tenants T1 and T2 and a bulb such that the bulb is used only by one of the tenants at one time, and that too if the landlord permits to do so. Have you understood the problem? The problem is there is a bulb, there is one landlord, there are two tenants. Both the tenants use that bulb. Landlord says, say this bulb is to be used one person at one time, and that too if I permit to allow you to do so. So let us say, let us try to help the landlord how to make the circuit. How to make the circuit. For us, the circuits are, the landlord, tenant 1 and tenant 2 are three elements X, Y, Z. X to be landlord, Y to be one tenant, and Z to be another tenant. If landlord says yes, meaning thereby, what are the possibilities for these three statements? True, for there are 2 raised to power 3 possibilities. That means there would be 8 possibilities. Landlord, 1, 1, 1 means yes, yes, yes. Yes, 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 yes. No, 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 no. Then tenant 1, this is yes, yes, no, no, yes, yes, no, no. And tenant 2, yes, no, yes, no, yes, no, yes, no. These are the 2 raised to power 3 possibilities. The statement true, false, true, false, true, etc. Treat it like that. True, false, true, false, false, true, false, and true, false, true, false. These are so it says. Then what the Boolean function would be? See, because 1 and 1 means yes and yes. That means both are using the same bulb. Landlord says nothing, the result is 0. Then landlord says yes, one of them uses, then fine. This is a fine situation. This is landlord what landlord wants. This would be X for L, Y for T1, and 0. This means Z dash. And this is yes. This is a good statement. This is a good one. And second one is also good. And all others are no, because landlord is saying no in both the cases. Meaning thereby, what is the first one where it is yes? It is X, Y, Z dash. And second is X, Y dash, Z. This is one. These two should be either of these two, meaning the Boolean function. The first one is X, Y, Z dash, and the second one it is X, Y dash, Z. And that means X or Y dash, X, Y dash, Z. So far, only on paper. Now let us come to practical. Practical says X is in series and Y dash Z. YZ dash and Y dash Z, they are in parallel, and X is in series with the both. Meaning thereby, if you see the first connection, Y and Z dash, they are in series, Y dash and Z, they are in series, and both of them making their union, both plus, they are in parallel, and that is in series with X, meaning thereby this one. X, Y, Z dash, and Y dash Z. And if you come to wires, now put that in wire form. That is, Y is connected with Z dash, because when we press the bottom, then it is on. When you press the upward portion, then it is off. So Y is connected with Z dash, and Z is connected with Y dash. They are connected like this, and both of them are connected with X. This is X, the third one, where it is not written, but it is X, X to the left, X to the left, no? And the connection should be, because if it is on, then one of them would be connected, Y with Z dash, and if it is off, then it is off, and one of them would be, you can see the connection is like that. You see, if and the lecture had not been online, I would have shown you the connection also in the true form, that this is the connection, that X is connected with that. This is the required connection. This is how the Boolean algebra, this is how the study of proposition, this is how what the logic says, Aristotelian logic, Boolean logic, set theory, yes, no, true, false, they come in practice. In practical form, this is the application. But the question is this. Question is that all these are application, of course, the study of logic, two elementic logic, yes, no logic, true, false logic, 0, 1 logic, whatever you say. But is this practical life? Practical life is little different. Why different? Suppose after this my lecture, if you ask two different persons, to one person who has understood the lecture very completely understood the lecture, and one person who has not understood. If you ask them, how about the lecture? What do you say about the lecture? Both of them would give you different opinion. One will say very good. The other will say no, no. And the third one, who has not understood the lecture at all, he would say very bogus. No, I have not understood anything. That means the people, same thing is there, but people have different opinions, different way of thinking, different way of talking about. See, my next one is an introduction to what happens in practical life. Practical life is, I would say, more of it is fuzzy. It is not elementic logic. Two elementic logic always fails. We cannot say that this element belongs to this set with definiteness. To introduce what is meant by a fuzzy set and fuzzy logic, we explain the following notion. The first one, certainty versus uncertainty. Let us begin with this story of an experience. 6 blind men came across an elephant. Each of them touches it to determine what it is. The one who touches the animal's side says it is a ball. The one who touches the animal's leg says it is a pillar. The third one, who holds the trunk, calls it a branch. The fourth one, who strokes the tail, says it is a rope. The fifth one passes his hand over the ears and believes it to be a window wang pan. And the last one happens to touch the task and is convinced it is a pointed weapon. Same person, same thing, but 6 people have different opinion. Each is sure of his own surmise and that of the other as false. As they quarrel, a person appears and listens to their respective opinions. He informed them that each one is correct in his own surmise, but that in order to come to a conclusion about the whole, they need to synthesize their individual opinions. This is what happens in practical life. This is what happens. Most of the time in day-to-day life, we are not clear about a situation, not sure. In other words, putting in language, we are fuzzy about a situation. What fuzzy means? Dictionary word of the fuzzy is not clear, not definite, not sure about anything, not definite about something, not clear, but we are fuzzy about the situation. To some extent, we say, some extent it is right, some extent. You see, you are right to some extent, wrong to some extent. Like that, we keep on talking about. Yeah, as I gave and told you about the lecture. Somebody would say, good lecture to some extent, and not good lecture. To me, of course, it's not clear. Like that, people talk about this. People talk in this way. As fuzziness deals with vagueness, uncertainty. There are two views of the concept of uncertainty. Two views. One is traditional view. Study of science means study of precision, exactness, specificity, sharpness, certainty. Uncertainty is undesirable in science and should be avoided by all possible means. And this uncertainty is regarded as unscientific in a traditional way. But modern view is, according to modern view, uncertainty is essential in science. It is not only unavoidable, it has great utility also. In general, we deal with problems in terms of systems that are constructed as models of either some aspect of reality or some desirable man-made object. Constructing a model, we always attempt to maximize its usefulness. This aim is closely connected with the relationship among the three following characteristics of every system model. What are those three characteristics? One is complexity, second is credibility, and third is uncertainty. However, uncertainty has a pivotal role in any effort to maximize the usefulness of system model. Allowing more uncertainty tends to reduce complexity and sometimes increases credibility of the resulting model. The shift from the traditional to modern view began in late 19th century when physics started analyzing process at molecular level. Although laws of Newtonian mechanics were appreciable to these processes, however, because of the large number of entities involved, then analysis required computations which were far beyond the computational capabilities at that time. The real life situations are often uncertain and vague in nature due to ये स्लाइड मूव क्यों नहीं कर रही डॉक्टर राजीव डॉक्टर राजीव
यस सर
हाँ स्लाइड मूव नहीं कर रही
सर आप क्लिक करिए पहले स्लाइड के ऊपर फिर उसके बाद मूव करके कोशिश करिए उसके बाद हो जाएगा क्लिक करिए पहले एक बार और तब फिर नेक्स्ट
हो गया The real life situations are often uncertain and vague in nature due to lack of information. The future state of the system might not be completely known. It is an interesting paradox that data based on uncertain situations provide us, in fact, with more accurate evidence about real phenomena. Yeah, it's an interesting paradox. Look at the paradox. Paradox says that data based on uncertain situation provides us, in fact, with more accurate evidence about real phenomena than data based on situations that are certain. The important point can hardly be expressed better than the following statement made by Albert Einstein in 1921. What Albert Einstein commented? He says, so far as laws of mathematics refer to reality, they are not certain. And so far they are certain, then they do not refer to reality. Reality is away from all these. Look at so far as laws of mathematics refer to reality, they are not certain. And then when they are certain, they do not refer to reality. Let's see what history of fuzzy set theory says. Look at this picture. He is so-called father of fuzzy set theory. It is now generally believed that an important epoch in the evolution of modern concept of uncertainty was the publication of seminal paper by Lotfi Asghar-Zadeh in the year 1965. Not long back, it is only just 1965, when he talked about fuzzy set theory, etc. In which paper? In the paper Information and Control, 338 to 350, in the year 1965. This is Professor Zadeh's picture, and of course, details are given over here. And he was born on February 12, 1921, and so on. 21 means 44. At the age of 44, he founded the notion of set theory. Zadeh, in his paper, Zadeh in this paper gave an account of modern concept of uncertainty. Although the idea presented in his paper was envisaged some 30 years earlier by the American philosopher, please check the spelling. It is Philos. O is missing. Please add philosopher. Philosopher Max Black in the year 1937 precisely. I would like to refer to Lord Buddha in the context of these ideas. What Lord Buddha said much earlier than these people. Lord Buddha emphasized that this world is manifestation of compromises, good and evil, virtues are in missing here, virtues and vices, pain and pleasure, being and not being. They always coexist. Our lives and events are characterized by fuzziness, lack of correctness. See, fuzziness was talked about Lord Buddha long ago, before before Zadeh wrote his paper. Professor Zadeh also remarked the following. People do not require precise numerical information input, and yet they are capable of highly adaptive control. There are classes of objects. There are classes of objects encountered in the real physical world which do not have precisely defined criteria of membership. For example, consider the collection of all small natural numbers. What is meant by small natural number? For one person, small may be just one. For another person, 1,000 may be small. So it is a relative thing. The collection of all small natural numbers, or all students with brilliant academic career, or the collection of all tall men. Who is tall? Tall is a relative term. Small is a relative term. See? All the collection defined above do not constitute a set in the usual mathematical sense. Yet the fact remains that such imprecisely defined collections play an important role in the human thinking, particularly in the areas of pattern recognition, communication of information, etc. An important point in the evolution of the modern concept of uncertainty dealt by Zadeh in 1965 in his paper was that he introduced a theory exploring a preliminary concept for such ambiguity. In his paper, Zadeh laid the foundation of fuzzy set theory. Fuzzy set theory is the concept and technique which lay a form of mathematical precision to human thought processes that in many ways are imprecise and ambiguous by the standard of classical mathematics. The behavior of fuzzy set is similar in many senses. with that of ordinary set, but is more general than the later. Fuzzy sets are the sets with boundaries not precise. The membership in fuzzy set is not a matter of affirmation and denial, yes or no, true or false, but rather a matter of degree. It has much wider scope of applicability and provides a natural way of dealing with problems in which source of imprecision, please correct the spelling of source, SOURCE, source of imprecision is the absence of sharply defined criteria of membership in the sense of two-valued logic. In fact, Zadeh's paper in 1965 on fuzzy set theory not only challenged the role of probability theory. See, sometimes it is confused with probability theory, but it is not. Fuzzy set theory not only challenged the role of probability theory as the sole representative of uncertainty, but it also questioned the very foundation of probability theory, which is primarily based on two-valued Aristotelian logic. Because probability is based upon whether it belongs to that set or not is clear. It is not clear. The either head or tail, not that head or tail, to some extent it is head, to some extent it is tail. No, it is not. Head or tail. The probability is based upon these concepts, two-valued Aristotelian logic, according to which X, the member of the set A, is either true or false, and there is nothing in between. According to fuzzy set, X, the member of the set A, may not be either completely true or completely false. It may be true to some degree. Why we need fuzzy set? Why at all we need fuzzy set? We do really need, because fuzzy sets are around. Only yesterday, not yesterday, this morning itself, I was talking to one of the professors, and I told him that I am to deliver a lecture at 10 o'clock at NDU, and he asked me about the topic. I told that it is so. And you see, why at all? See, fuzzy sets, and where do fuzzy sets exist? I told him, look, in practical life, we have fuzzy set theory always. You start constructing a building and you say that I think the building should be over, say within 6 months. But suddenly your laborers, your mason, etc., they go to their village and they tell you that they would be coming after, say, 15 days. But they do not come, for 2 months. What is this? This is fuzzy set theory. You approximate something based upon something. That's not going to be true. Because the practical life is fuzzy. We are not sure about the situation. Sometimes, you place an order, place an order for cement, etc. And people, they say, the shopkeeper says that it will reach you within, say, 1 or 2 days. But it doesn't come for many days. This is what is caught. Because we are always living in fuzzy situations and we are to approximate them. We are to make use of fuzziness in the real sense. We are to, the reality is fuzzy. The reality is not yes or no. The reality is something in between. That is what is fuzziness. Yeah? So I think why fuzzy sets there should be, because we need them. We need them always because they exist in practical life. We may observe that in the definition of a crisp set, the boundary of the crisp set is rigid and sharp. An element X may belong to it or not belong to it. There is no in between. Moreover, all the members of the set are equally important. There is no high or low among the members. The definition of the set, which was essentially formulated by Aristotle over 2000 years ago, has dominated the thought process ever since and has served reasonably well. We have worked with that very reasonably. Things have worked out. That is not the practical life. However, still there are situations in which this definition does not meet the desired objective very well. There are situations in which the boundaries of the set are not sharply defined, or all the elements of the set cannot be assigned equal importance. I'll give you an example where all the elements of the set they cannot be assigned equal importance. The, uh, in some part you can say this works well belongs to or doesn't belong to. All the elements they enjoy the same situation, but not always. For instance, suppose we want to represent the set of intelligent students in a class in the classical set theory. Classical set theory, either intelligent or not intelligent. Hmm? Then it will require us to choose a threshold value for the mark to be, say, 75. We say anybody who is securing less than 75 is not intelligent. Anybody who is securing more than 75 or 75% or more is an intelligent. But is it practically the same for a student? So our set will consist of all the students who score 75 marks or more. Now the question arises, is 75 so important that a person securing 75 is intelligent, but a person securing 74 is not intelligent? Or are we justified in assuming that a student who has scored just 75 out of 100 is as intelligent as a student who has scored 90 or 95 or even 100 out of 100? Are we justified in saying this thing? Our conscience will say no. A person who has scored 100 out of 100 and a person who has scored 75 out of 100, there is a difference between the two. But classical set theory says same importance. But fuzzy set theory says no. There should be a difference. Our case set theory compels us to do so. However, this is not very acceptable in real life. Similarly, there are several life situations such as set of tall person, set of healthy person, set of comfortable houses, etc., where crisp set theory prove inadequate, incomplete, and depicting the true situation. True situation is not depicted in set theory. True situation is depicted in fuzzy set. To deal with such type of situation, where a set is not expected to have a precise boundary, or there is no justification in according equal status to all the members of the set. How the fuzzy sets are represented, I'll let you know. An ordinary set is a collection of definite and well-distinguished elements. This means elements are non-repeated, and given an element, it must be possible to determine that whether it belongs to or doesn't belong to this collection. Let U be the universal set, and let A be a subset of it. On the set U, we can define a function f from U to set 0, 1 as fx is equal to 1 if x belongs to A, fx is equal to 0 if x doesn't belong to. This is called the characteristic function of the set A. This is the ordinary crisp set theory, or say Aristotelian set theory, or Aristotelian logic. F is called characteristic function of the set A, or a membership function defining a set. All the mathematics built on set theory grew by leaps and bounds. The collections which are not definite or not distinguishable are not mathematically modeled. But such collections always exist in nature, occur in nature. Economics, linguistics, information theorists, biologists, psychologists, sociologists are encountered with such aggregate, or given an object of such collection. It is not possible to determine precisely whether it belongs to collection or not. For instance, there is no specific demarcation between tall and short, or between handsome and ugly, or between handsome and not handsome. And there are people who are nearly handsome. In between handsome and ugly, there are people who are nearly ugly. Such collections were deprived of mathematical structure until they defined fuzzy set. Precisely, the collection A of real numbers close to 5 but greater than 5 is not precise. This is a fuzzy set. For this, that f be a function from R to 0, 1, closed interval 0, 1. The set 0, 1 is replaced by the closed interval 0, 1. No, generalized, you can say, not only just replaced, you can say it is generalized to the closed interval 0, 1. As the set theory is generalized for the set, the corresponding function, membership function, which the range was only the closed and the set 0, 1, is now generalized to the closed interval 0, 1 to represent fuzzy set. Fa of x is equal to 0 if x is less than or equal to 5, and Fa of x is equal to x minus 5 by x if x is greater than 5. X minus 5 by x will always, x greater than 5 will always lie between 0 and 1, you can see. So Fa is called the membership function of the set A. The graph is before you. It is represented like that. If x is the set of, say, 26 English alphabets, and mu is a function from x to 0, 1, we define that mu x is equal to 1, when x is a, e, I, o, u, and 0 otherwise, then the fuzzy subset mu, which is a collection ordered pair x mu x, x belongs to x, is the ordinary subset of the vowels. Thus, the collection of fuzzy set includes the collection of ordinary subsets as special cases. Consequently, all the notion and results are for the subsets are valid for the ordinary subset. This means that fuzzy set theory is nothing but the generalization of the ordinary set theory, where the characteristic functions are generalized to membership functions of 0, 1 to the closed interval 0, 1. If sometimes people may think that there is, I don't know what is meant by fuzzy, but I'll justify that there is nothing fuzzy about fuzzy set. There is nothing fuzzy about fuzzy set. In the fuzzy set literature, describing a fuzzy set means only a clear definition of an ambiguous set. For instance, in any example we take, once the membership function mu ax has been defined, then there is no ambiguity about the elements under consideration. Once we define it by a membership function, then there is nothing fuzzy is left. Everything becomes clear. It is no longer ambiguous, or as we say, there is nothing fuzzy about the fuzzy set. From the mathematician point of view, the word fuzzy may be viewed as a name selected to distinguish a class of set in which a membership function mu x of its elements can have values other than 0 or 1. This is just like an imaginary number in complex function theory. There is nothing imaginary about these numbers, but these numbers are called imaginary. These numbers are used for quite real application. The term imaginary is used just to indicate that this is a different class than class of real number. Logic versus fuzzy logic. Logic is two-valued logic based on different laws. The true value of any proposition is either yes or no. There is no other answer in between yes and no. But human thought processes are imprecise, and these allow partial truths between yes and no. However, half truth and half falsity is not allowed in two-valued logic. In two-valued logic, TS, the truth value of the statement S is either 1 or 0. But in fuzzy logic, it is not necessarily so. In fuzzy logic, a proposition is called fuzzy proposition. S is a statement involving some concept whose truth value could be any value between 0 and 1. Linguistic statements used in natural language in fuzzy logic are imprecise and hence are fuzzy propositions. In crisp two-valued logic, we always assign a crisp set to a universal set, and in fuzzy logic, fuzzy propositions are assigned to fuzzy subsets. Suppose a fuzzy proposition P, whose truth value is denoted by Tp, is denoted by Tp equal to mu x, where mu x belongs to 0, 1. Thus, the degree of truth for the proposition P is the membership value of x in the fuzzy set A. For example, in the fuzzy set of bald person, a person is valid can be represented by assuming a suitable truth value between 0 and 1. The lower the value, lesser is the baldness. Value 1 means totally bald. Value 0 means not bald at all. As another example, let the variable x be air temperature at some particular place on Earth, and let the following figure represent the high temperature in Fahrenheit shown by the membership function mu and mu a for the fuzzy setting. That T is the proposition temperature is high at some place. The degree of truth PP depends on the actual value of the temperature and on the given definition of the high temperature. You can see these two graphs represent that how from the proposition you can get to its truth value. It is defined by the membership function. For example, if x is 85, then mu a x is 0.75. Look at the graph. It is 0.75. And therefore TP is 0.75. But the role of the function T is to provide us with a bridge between fuzzy set and fuzzy proposition. The logical connectives of negation, disjunction, conjugation, and implication for fuzzy logic are given as follows. Proposition P and Q we define for the fuzzy sets A and B respectively, and P dash U dash negation. Then TP dash is 1 minus TP. T of P union Q is maximum of these two. And T of P intersection Q is minimum of these two. And T of P implies a TP dash of this is maximum of TP dash and T. The goal of fuzzy and logic is to formulate the mathematical foundation for reasoning about imprecise proposition. Such reasoning are termed approximate reasoning by Zagay. Application of fuzzy logic. Kindly, I am coming after taking a glass of water. Good morning. Morning. उठाइए बेटा. हाँ. देखना जरा पहले. नहीं. Friends, I'm beginning with applications of fuzzy logic. Well, nothing in mathematics is complete without showing its application. So is that view of fuzzy logic. At present time, fuzzy logic is a fairly advanced topic. It finds applications to civil, mechanical, industrial, electrical, and computer programming, along with reliability theory, pattern recognition, image processing, and other engineering branches. It also finds application in other disciplines like medicine, economics, networks, natural sciences, and psychology. However, we present here what? Present here the application to fuzzy let fuzziness comes into. State fuzzy linear programming, let us first understand ordinary classical linear programming problem as follows. This linear programming problem maximize z equal to x1 minus 2x2 such that with these boundary conditions, px1 minus x2 is greater than or equal to 1 and 2x1 plus x2 is less than or equal to 6. Where x2 is greater than or equal to 0, less than or equal to, and x1 is always greater than or equal to. What is that we do? We draw two lines, 3x1 minus x2 equal to 1 and 2x1 plus x2 equal to 6. And these one, see, and mark the region, see x2 greater than or equal to 0 and less than or equal to 2, and x1 greater than or equal to 0. Then look at this line to the left, it is 3x1 minus x2 equal to 1. And to the right, right hand side, it is 2x1 plus x2 is equal to 6. And then x1 greater than equal to 0 is the right hand side. Right hand side means that this portion is x1 greater than equal to 0 and this is x2 greater than 0. And then
Yes, dear participant, there is some issue from the end of Professor Arora. So please bear with us. There is some issue of network connectivity at their end. Arora sir, am I audible to you? कॉल कर लो कॉल किसको कर
Anju ji? Anju ji, this is Dr. Urvashi Arora.
Should I begin?
Yes, sir.
Okay. I am reading fuzzy linear programming problem. Assume that a company makes two products. Product P1 has rupees 0.40 per unit profit and product P2 has rupees 0.30 unit profit. Each unit of product P1 requires twice as many labor. The total labor hours are at least 500 hours per day and may possibly be extended. Look at the fuzziness over here. The total available labor hours are at least 500 hours per day and may possibly be extended to 600 hours per day due to special arrangement for overtime work. The supply of material is at least sufficient for 400 units of both products P1 and P2 per day, but may possibly be extended to 500 units per day according to previous experience. This was not possible in linear programming problem, ordinary crisp linear programming problem. This is only fuzziness that allows you. The problem is how many units of product P1 and P2 should be made to maximize the product. Look at the fuzziness involved in the problem and look at, of course, we'll solve it by those methods. Solution. Let x1 and x2 respectively denote the number of units of product P1 and P2 in one day. Then the problem can be formulated as the following fuzzy linear programming problem. Maximize z of 0.4 x1 plus 0.4 x2. This would be the, of course, profit, such that x1 plus x2 is less than or equal to b1. b1 refers to this constant, refers to material. 2x1 plus x2 is less than or equal to b2. This refers to labor hours, which of course they are fuzzy. b1 and b2 are fuzzy. x1 is greater than or equal to 0 and x2 is greater than or equal to 0. Where what is b1 and what is b2? b1 x is equal to 1 when x is less than or equal to 400. 500 minus x divided by 100 when x is greater than 400 and less than less than or equal to 400, and 0 when x is 500. This was the constant b1. Constant b2 is b2x is equal to 1 when x is less than or equal to 500, and 600 minus x divided by 100 when x is greater than 500 to less than or equal to 600, and this is 0 when x is greater than 600. First, we need what we do. We need to calculate the lower and upper bounds of the two following classical linear programming problems. What is that? Where you are taking this, then x1 is less than or equal to x1 plus x2 is less than or equal to 400, and 2x1 plus x2 is less than or equal to 500. This is one classical linear programming problem. And second is when x1 plus x2 is less than or equal to 500 and then 600. Because the first one was between 400 and 500 and second one was 500 to 600. These two classical linear programming problems are solved, and they are solved in the usual sense which we do, that and we obtain z of f to be equal to 130 and z of O to be equal to 160 in both the cases. The first case, second case. Then what is that we are in? So the fuzzy linear programming problem becomes solving the classical. Again, please change everything to classical. We are solving with the help of classical the fuzzy linear programming problem. Classical optimization problem using simplex method. And as follows: maximize lambda, that lambda into z0 minus zf minus 0.4 x1 plus 0.3 x2 less than or equal to minus of zf. 30 lambda is the difference between the two, and this becomes 30 lambda minus 0.4 x1 plus 0.3 x2 less than or equal to minus 130, and 100 lambda, because 100 is the difference between 600 and 500 lambda plus x1 plus x2 less than equal to 500, and 100 is the difference between 500 and 400. 2x1 where material and labor, 2x1 plus x2 less than or equal to 6, x1, x2 and lambda greater than or equal to 0. Solving this classical linear programming problem with the help of simplex method, we obtain maximum of value of lambda is 0.5, where x1 equal to 100 and x2 is equal to 350. And therefore, when x1 is 100 and x2 is 350, we get the value of that maximum profit is 0.4 into 100 plus 0.3 into 350, and that is 145 rupees. This is how classical linear programming problem is solved. Well, the lecture would be not complete if I do not tell you the required references, from which I have taken the material, from which I have done the whole thing. Okay, this is 1, 2, 3, 4, 5 is one, and 6, 7, 8, 9, 10, 11, 12. Anybody who wants to develop all these things and go for further reading and further developing the topic can refer to these books and research papers and get the things done. Thank you all. Thank you very much. I ask for questions if any. Well, I'll try to answer whatever is possible. Okay. Thank you. Thank you very much. Thank you all.
Thank you so much, sir. So I can see one question in the chat box. What is the main or a clear distinction between probability theory and fuzzy theory?
We know the difference. See, I told you probability theory and fuzzy theory. Probability theory is based upon, once again, between two elementic logic. The Aristotelian logic, 0-1 logic. In probability theory, we are sure whether this element belongs to that set or not. While fuzzy set theory is nothing so-called generalization of that. I tell you, somebody asked me, sometimes back, I delivered a lecture at some place, I don't remember, in some university. And the same question was asked. Well, do you understand the difference between rational numbers and real numbers? Rational numbers is, what is a rational number? It is P by Q, where P and Q are integers. And real numbers is generalization that. See, fuzzy set theory and probability theory, you can correspond to these. Fuzzy set theory is generalization of probability theory. As real numbers are generalized from rational numbers. Same difference. That is dependent upon two elementic logic. This is a line also in my lecture. That fuzzy set theory challenged the probability on which the very foundation of probability theory. That is based upon, once again, Aristotelian logic. While fuzzy set theory is generalization of that. I hope it is clear or not yet. Fuzzy set theory is generalization of Aristotelian logic, probability theory, because the very root of probability theory is, based upon definiteness, whether it belongs to that. And this depends upon membership function. 0-1, belonging, not belonging, whereas fuzzy set theory is generalization of that theory to elementic logic.
Okay, thank you, sir. One more question is there. What is the state of the law of the excluded middle when it comes to fuzzy logic? Is it still valid?
That is not.
Okay, sir.
Excluded middle. See, excluded middle. That is something belongs or not doesn't belong. Whereas fuzzy logic says it goes slowly. Where is the boundary for that the excluded middle? No boundary. And therefore it is not.
Anybody else want to ask anything? Okay. Thank you, everyone. Thank you so much, sir, for your beautiful presentation. Now, I request convener of this faculty development program, Professor Rajiv Kumar, for the formal thanks. Over to you, sir.
Thank you, Dr. Ekta. Respected Professor S.C. Arora ji, a fatherly figure for me and of course a well-known mathematician. We pay gratitude and really obliged that being at this age, at the health situation, you have given consent for delivering your expert lecture on this FDP, sir. I was not clear whether in digital platform you will be able, but you have wonderfully presented your expert talk, sir. Professor Arora always bless us and always take up so many assignments and for MDO only. Awarded many PhDs and given many lectures every conference and any FDP. He is always there and he's a part of our family. So thank you. What about regarding your lecture? It was very simple, in simple words, and presented in a very lucid manner, taking care of all real life situations, how logic to fuzzy logic we can connect. And really, you have rightly said that fuzzy set theory is a generalization of the ordinary set theory, and even I'm being a fan of probability theory. It is a fuzzy theory is a generalization of that probability theory also. And you have beautifully taken example of politicians. Many times you have repeated about their wrong statements and serving pickles by the wife. And I mean, you have taken care of all practical situations that we used to have, and how you have connected those situations with your these concepts, which seem to be very difficult. Really, you have uh, kept nothing fuzzy is about fuzzy set. So that too, I too feel I'm not fuzzy now regarding the fuzzy set. So thank you so much, sir. Wonderful talk, and I think I hope that every participant has got a best of this presentation, and they will definitely benefited by your expert talk, sir. So thank you very much, sir. Once again, on behalf of myself, my department, the FDP organizing team, and Maharshi Dayanand University Rohtak. Thank you once again, sir. Thank you so much.
Thank you. I have to say one thing.
Welcome.
Sir, in your thank giving this process, you have mentioned that I have awarded PhD. I say I have not awarded. I have given my accordance to what the student supervisor department has done and what the examination branch MDU has done. You see, I have just said, yes, it is so. Nothing else. My contribution is nothing. Nothing except to say that this merits PhD degree or MPhil degree, etc.
Thank you so much. This is the your humbleness. That's what.
No, no. I'm very clear about my role.
A person like you, who is just a legendary personality of mathematics, used to say a word like this. So thank you, sir, so much. We are always having listening of you, and of course, all the participants has got a lot of this, and they can ask even any other query if they have. They can ask. We can provide the contact number as well as the email ID of Professor S.C. Arora, so you can clear your concept. Is a it's a wonderful work in this area. Thank you so much, sir. Thanks.
Right. Thank you. Thank you. Thank everybody. Thank, including the participant. Thank for patient listening. Thank to all of you. Thank to you in particular. Thank you.
Thank you so much, sir. Thank you, Rajiv, sir. So now, participants, it's a time for tea break, and the time will be shortened because of the timing. It will be of 20 minutes only. So please be present before 5 minutes before the session. So up to 12, there is a tea break. So please be here at 11:55 so that we can start the session on time. Attendance link is shared in the WhatsApp group also, and that will remain active up to 12 p.m. only. So please fill that form in 20 minutes, and after that we will close that form. So please use your WhatsApp group to fill the form now.